What is configurational entropy in thermodynamics? Imagine you have a box filled with tiny particles. How these particles are arranged in the box affects the overall disorder of the system. That's what configurational entropy is all about. It measures how many different ways the particles can be positioned without changing the system's overall state. Think of it like shuffling a deck of cards. The more ways you can shuffle it, the higher the disorder. In thermodynamics, entropy is a way to quantify disorder or randomness. It tells us how many microscopic arrangements correspond to a particular macroscopic state. Configurational entropy zooms in on the arrangement of particles themselves, ignoring their energy or movement. It's all about where the particles are located. For example, picture a box with gas molecules. If all the molecules are crammed into one corner, the configurational entropy is low because there are fewer ways to arrange them. But if the molecules spread evenly throughout the box, the number of possible arrangements skyrockets, and so does the configurational entropy. This increase shows how systems naturally tend toward more disordered states. When two different substances mix, the configurational entropy jumps. This is because the particles from each substance can be arranged in many more ways once combined. This increase in disorder is a key reason why mixing often happens spontaneously. The system becomes more probable and more disordered, which aligns with the idea that nature favors states with higher entropy. Mathematically, we express configurational entropy using the formula S equals Boltzmann's constant times the natural logarithm of the number of configurations. The formula is written as S equals K times lane W, where S is entropy, K is Boltzmann's constant, and W is the total number of possible arrangements. This relationship helps us understand how the number of configurations influences the overall disorder. Understanding this concept helps explain why spontaneous processes happen. When particles have more ways to be arranged, the system's total entropy increases, pushing it toward equilibrium. It's like a puzzle that naturally falls into the most disordered, most probable shape. In summary, configurational entropy is the part of entropy that measures how particles are arranged in space. It explains why systems tend to become more disordered over time and why mixing and other spontaneous changes happen naturally. It's a simple idea that reveals a lot about how the universe moves toward more probable states.